Hello, everyone, and thank you for attending today's webinar, Security Beyond Connectivity, the Safe Way of Connecting to the Cloud, featuring speakers from ECI and Level 3. Before we begin, I wanted to cover a few housekeeping items. On the right-hand side of your screen is the Q&A. If you have any questions during the webcast, you can type your question into the Q&A box and submit your questions to our speakers. All questions will be captured. So if we don't get to answer you, we may follow up via email. At the bottom of your audience console are multiple application widgets you can use. If you have any technical difficulties, please click on the yellow help widget with a question mark. Here you can find answers to common questions. A copy of today's slide deck is available for download in the green resource list widget. Towards the end of today's presentation, we'll ask for your feedback. A survey will pop up open on your screen and will only take 1 minute to complete. Your feedback is extremely helpful. An on-demand version of the webcast will be available approximately 1 day after the event and can be accessed using the same audience link that was sent to you earlier today. I would now like to turn the event over to Light Reading's founder and CEO, Stephen Saunders. Steve?
Thank you so much, Ali, and thanks for that introduction, and welcome to everybody on the event today. Welcome to all of you. There are over 600 registrants for this event, which is a very large number, obviously, but I can't say that I'm entirely surprised because as we've learned over the last 15 years at Light Reading, security is a perennially hot issue for the network architects that we target. And when you talk about security in the context of the cloud, well, that's when you really are hitting the focus of a lot of attention and energy right now within the communications industry. And that's not a speculative statement. We know that for a fact. At the end of last year, Heavy Reading did a survey of 400 service providers, and we asked them what they thought or what they predicted would be the biggest obstacle to monetizing high-capacity networks, their high-capacity networks, through the end of the decade. And their answer, the number one answer, was security, not virtualization or capacity or reliability or any of the things that we were preoccupied with in the last century, but security. So it really is an absolutely critical issue. And I'm very happy to say that we have a really, truly an expert panel today to discuss this topic. I'll introduce them now. First, a long-term colleague of mine from Heavy Reading, Sterling Perrin, who's Senior Analyst at Heavy Reading. I believe you're coming up on your 10-year anniversary here, Sterling. Congratulations on that, and welcome to today's event.
Thanks, Steve. And yeah, great to be here today, and good morning, everyone.
Good morning. And then next from ECI Telecom, Director of Portfolio Marketing, Jonathan Homer. Jonathan, welcome.
Thank you very much, Steve. I look forward to participating.
Thanks for being here. You know, ECI is has a reputation as a packet optical transport pioneer and really has built its reputation on success through innovation. I mean, relative to some of the other companies in our industry, it's not one of the largest companies, but it's managed to compete successfully against giants like Cisco and Huawei for many years based on outstanding innovation. And now it's turned its focus to security. And obviously, as an Israeli-based company, it has the benefit of a lot of in-country expertise in tackling that topic. So really, we couldn't wish for a better educational partner on this event today than ECI Telecom. Also today, our service provider expert witness, if you will, Joe Cudby, Senior Director of Professional and Government Security Services at Level 3. Joe, welcome to the event today. Thanks for being here.
Thanks for having me, Steve. I'm looking forward to the conversation.
Yeah, Level 3 has been a long-term partner of Light Reading in this type of event. Of course, you know, we worked with Level 3 for a long time. It's a much bigger company than it used to be. It's actually $20 billion big right now, so it may be called Level 3, but it's certainly not a Tier 3 operator. In fact, it's no longer a Tier 2 operator. By virtue of, really quite a rampage of acquisitions, it's now officially a Tier 1 operator. So we're really delighted that Level 3 could be with us today. But I'm going to kick this back now to Sterling. And Sterling, I believe you're going to give us an overview to tee up the event today. Over to you.
All right. Thanks a lot, Steve. So what I want to do is just really set the stage for the other speakers, and I've just got 3 slides here to hopefully do that, starting at a high level and then getting a bit into security. But on the first slide here, what I wanted to do is take a look at the impact for cloud as well as data center on network traffic, which the network, of course, is what I spend my days looking at. And in this case, looking at IP traffic specifically. The data on this chart is taken from Cisco's very widely cited Global Cloud Index model, and there's a little bit of analysis I've done from their Visual Networking Index. Of course, these are both very widely cited sources for traffic in the industry. So this figure shows data center IP traffic volume, and it's out through 2018, and it's measured in exabytes per year. That's on the left-hand side. And I broke it out by cloud data center IP traffic and then traditional data center IP. So traditional data center is any services that are not cloud-based, essentially. You can see even in 2013, cloud comprised more than half of total data center IP. And then if you look at the 2018, the cloud data center IP moves to more than 3/4 of that traffic. And the CAGRs are written out there too, 4 times faster growth for the cloud data center versus the traditional data center. The other significant point from this is, or from their studies, is that the data center to user traffic is more than 80% of global IP wide area traffic even today. So this is the portion of data center traffic that leaves the data center and goes out to the user, and that's something that's measured in their VNI model. And so that's already 80%. So it's a huge piece, and it's moving to cloud. Clearly, there's a lot of impacts for the network, things that Steve mentioned in the beginning in terms of scalability, flexibility, dynamic provisioning, lower latency, and all these things we've traditionally looked at, as well as what we're going to talk about today, which is security. And that does tend to be the piece that's been focused on less, and so we're going to kind of shine the spotlight on it today. The next slide that I've got looks at Metro 100G transport specifically. This is heavy readings forecast for Metro 100G line-side ports out through 2018, and this includes all applications for Metro 100G. We are working on a data center interconnect forecast currently, and which is embedded in here. I will say that data center interconnect is the biggest driver of the 100G deployments that we're seeing in the Metro over the next several years. And so a big contributor to that 74% CAGR. And actually, as we do the revisions of the forecast, if anything, the numbers are going to go up. I think this initial cut at things was a bit conservative, and so data center interconnect is really driving a lot of that 100G growth. Final slide I've got here, I want to tie it into security, and I'll focus specifically on optical layer encryption on this slide. When I hand things over to Jonathan, he's going to talk a bit more broadly about network security and encryption across different layers. But if you think about the trends that I highlighted on the previous slides, it really is making optical layer encryption much more relevant than it's been in the past, which is why I want to highlight it a bit. One of the key benefits to optical layer encryption is the extremely low latency that it brings to the process of encryption. And this can be critical for certain applications that are very latency sensitive. When you're encrypting, the thing you need to keep in mind is that you're adding latency on top of whatever latency is already included in that transmission. So there's the distance, and then there's passing through the different electronics, and then you're adding latency on the encryption. And that can be a deal breaker for certain applications. So I've got a couple of statistics here. In layer 3 encryption, using IPsec adds in the milliseconds range of latency just for the encryption. Layer 2 at 10G transmission I've highlighted here is in the microseconds kind of range. If you look at the optical, even at 100G transport rates, it's adding less than 150 nanoseconds of latency. So very extremely low latency, again, which can be very critical for certain applications. The next piece, which is somewhat related, is extremely low overhead. Higher layer encryptions are adding a lot of overhead bits to do the encryption. And those added bits, essentially what they're doing is reducing the actual payload. So the payload of that encrypted traffic can be well below the line rate of whatever transmission. In the case of layer 3, which adds the most overhead, if you're looking at small packet sizes, it can be as much as 50% reduction in your actual throughput of that payload. And then at layer 2, again, for smaller packet sizes, around 20%. The final point I'll make does relate specifically to 100G. As I just talked about on the last slide, we're seeing a massive migration of data center interconnect from 10G rates to 100G, particularly for the large Web 2.0 giants, the Googles, Yahoo, Facebook, and this type of provider, where they're moving essentially exclusively to 100G rates for their data center interconnect. What we've seen, at least so far, in a lot of the higher layer encryption products that are going out and addressing data center interconnect, is they're set to 10G rates, which is not really a match to where we're seeing those lines moving. And so we see this as clearly a very strong opportunity for data center interconnect in 100G for encryption going forward. And so with that, kind of setting the stage generally and a little bit of a sneak peek into optical layer encryption, what I want to do now is bring in Jonathan from ECI, and they will give the ECI perspective on encryption and security across different layers of the network. So Jonathan, I'll hand it over to you.
Thank you very much, Sterling. This is Jonathan Homa, and today we will look at cloud networking from a slightly different perspective, from that of security. We'll look into what are some of the security concerns for moving to the cloud and how can we address these. I just want to mention that I also have with me in the room here David Gladstein. David is from ECI's cybersecurity group, and he'll be with us for the roundtable discussion to provide support depending on how deeply we get into some of these cybersecurity topics, including encryption and including higher level cybersecurity solutions. So, hooray, we're moving to the cloud. I think it's a very, very clear industry trend, an inexorable trend, you may say, that enterprises and businesses are moving their IT infrastructure to the cloud, and doing so for a variety of reasons, both from a customer perspective, their own workforce perspective, and an overall performance and cost perspective that is just making more and more sense to move the IT infrastructure from the close confines of their own business, maybe their basement if you're an enterprise, or on their own servers and PCs, and moving these into a cloud which is remote from their own locations. Of course, they're doing this leveraging the fact that we have a highly efficient, high bandwidth communications infrastructure. So for those of us in the transport industry, and I think there's many of us on the call for that, you might argue that the cloud is a result of us doing our job perhaps a little bit too well. So being able to support this movement of the IT industry. However, moving to the cloud does come with a whole new set of concerns. When we had our infrastructure closely held, again, within our own premises, on our own servers, it provided a certain degree of additional security and oversight into the use of this particular IT infrastructure. When we move it to the cloud, it creates a whole new set of concerns, or perhaps taking some existing threats and now exposing them in new ways. One example, for instance, we have much, much greater use, of course, of communications. So this exposes our traffic in terms of going to and from the cloud to all sorts of interception and snooping to bad third parties. At the same time, there's the existing threats that we're probably familiar with of system infiltration and data exfiltration, which means the losing of data or data exiting your systems in an unplanned manner. But now these are recurring in remote data centers rather than a closely guarded local infrastructure. The good news is that there are solutions to these concerns, and we'll begin exploring some of these solutions in the webinar today. For instance, we can use multiple layers of encryption throughout the transport network to protect data against interception. And one of the areas we'll explore in particular is increasing use of layer 1 optical encryption. We also have suites of cyber tools available to us to protect against system infiltration and data exfiltration. These can become deployed with different emphases depending on the cloud model being used between public, private, and intermediate hybrid clouds, and the level of cloud services being used, for instance, namely the infrastructure, platform, or software as a service. Let's begin looking at encryption. So encryption and decryption occur at the endpoints of a communication session, and they can be performed at several layers of the OSI stack. Now, everyone on this call has seen the little green lock icon that appears in the address line of your browser. It might even be appearing for this particular session. What this is telling you is that this particular session is using a secure sockets layer, which is a part of the overall transport layer security that's available for web browsers. This was specifically created for web communication. However, it is now also starting to be applied lower down within the OSI stack. Other encryption layers that are perhaps not as visible to you, but that are being actively employed by your IT departments, are things such as IPsec, which occurs at layer 3, or there's also MAC layer 2 encryption, and what we'll talk about a bit more today is layer 1 optical encryption. Now, each successive lower layer encrypts not only the message payload, which is the heart of what you're trying to encrypt, but also the addressing information associated with any higher layers. Now this is an important point that some people might not totally appreciate. I'll give you an example. For instance, with IPsec, what it protects is the message payload. However, what it's not protecting is the IP level addressing information. So let's say someone's intercepting this message right now, or the stream of messages coming to and from your corporation that are only being protected by IPsec. Now, granted, they're not going to be able to very easily break into the payload and see what you're actually messaging, but they will be able to see who you're talking to, how often you're talking to those person, and how people are responding to you. And there's an awful lot of intelligence just in the messaging in terms of the traffic, in terms of to whom it's going to, where it's coming from, and the amounts of this data. And this kind of information could be very interesting to the bad guys trying to really hack into your network. It's really only layer 1 optical encryption that protects all the address information and also protects any other messaging contained in the optical stream that was not encrypted at all. So you can consider layer 1 optical encryption as the great vacuum cleaner of encryption. So you may ask, isn't it really hard to tap an optical line? I mean, it's optical, it's photons. How do you tap this? It's not like putting an alligator clip onto some piece of electrical wire. Well, the reality is that it's actually quite easy to tap an optical fiber. At the very low end, and maybe this is the most prevalent threat, is that you can use simple $50 clip-on devices, which you can just clip onto a fiber, maybe where it's exposed at a patch panel somewhere. It extracts an almost unnoticeable percentage of light, but with this very, very, very small percentage of light, maybe in the range of like less than 1%, you still have access to all the information carried by that light. And even at the very high end, for instance, if you think about optical fibers going underneath the ocean, it's been sort of revealed and discussed that the United States, even as far back as 15 years ago, has been using advanced technologies, cost a bit more than $50 clip-on devices, that have been shown to actually go to the bottom of the ocean and be able to monitor the traffic taking place over optical communications. So really the only defense against fiber tapping is layer 1 optical encryption. Now let's look at some of the elements of layer 1 optical encryption as we show in this particular example over here. This is showing a typical point-to-point link between an enterprise and a data center that is taking place over an optical link. So for instance, between an enterprise, maybe between some legacy equipment in the basement, or maybe between a server which is aggregating all the communications traffic from that enterprise office, or from a data backup in that enterprise office to some cloud-based applications. So again, it could be for access to hosted services, or just for backing up your network data on a storage area network. Between those 2 points, you have an optical link. So what are some of the key points about this optical link and how it's implemented, and about the layer 1 optical encryption? So the first point to emphasize is that it's client agnostic. Optical doesn't care what interface is being transported and encrypted. So it doesn't care whether it's an Ethernet interface, the fiber channel interface, or even if you have some old SONET SDH traffic taking place over it. Anything which is being transported transparently within the optical frame is being encrypted. A second point is that the optical encryption should work with both your currently popular 10G links and, like Sterling mentioned, increasingly popular 100G links. This is an important aspect. In terms of performance, like Sterling mentioned, one of the advantages of layer 1 optical encryption is that it does not add any overhead to the communication and takes place at what I would call near wire speed, perhaps adding an additional 100 nanoseconds of latency. How this gets encrypted is a whole sort of different presentation in itself, which I'm not going to go into today, other than to say it usually uses, or it should use, some public key exchange, for instance using a Diffie-Hellman scheme, to create a shared private secret key or session key. And then the session key itself should use a high level of encryption. We advocate something called the Advanced Encryption Standard 256. That means a 256-bit key with GCM extensions. What the GCM extensions do, make sure that if anyone is trying to tap into it, it lets you know, it flags some bits. And it also makes sure that no two messages are encrypted in the same way. And finally, as part of this encryption process and sharing the key, there is an authentication process using X509 certificates. And there's really two ways that this could be done, either just using self-signed certificates, which may be appropriate for small private networks that are very closed, or using third-party administration options for larger networks where you want to administer that yourself. So putting this all together is really part and parcel of what we see at ECI as an overall solid layer 1 optical encryption solution. However, cybersecurity in terms of moving to the cloud goes beyond just optical encryption. What we're looking for as well is how to protect against the system infiltration and data exfiltration. And here what we're doing is bringing into play cybersecurity. Now, for many of us on this call, cybersecurity might be a new topic, particularly if we come from the transport world. So I put this graphic together just to show at a very high level how this actually works. And the model that I like to use is that of a customs or immigration inspector at an airport. So you can think of the long, long lines of people sort of queuing up to see the passport inspector as your packets. And what the passport inspector is actually doing over here is taking a look at every single packet that's coming in to that network that's trying to be protected, and then providing a variety of functions, such as inspecting the packets. It could just pass it out of hand if it knows what it is. It might reject it out of hand if it knows what it is, or if it sort of fails some signature test. Or it could alert it, record it, flag it, and do some ongoing analysis of this, even though it gets passed and allowed to pass through. But using all these basic functions gives us the opportunity to construct security applications. So over here what we're showing is the LightSec security suite, which is being offered by ECI. At the basis for this is the layer 1 to layer 3 optical encryption that I've already talked about. However, this is enhanced by a wide variety of applications which have been either developed by ECI or where we're working with third parties and strategic partners within the Israeli security industry, including such names as Checkpoint, with whom we have a strategic partnership. So among these, reading through, and again, just to sort of provide very, very high-level overview of the kind of capabilities, we have secured site gateways and firewalls. We have strong authentication capabilities that guarantee user identity, and you can supplement these by recording the sessions, monitoring them and reporting them. In some cases, companies have different levels of networks, including some private networks within their private networks. So you can provide, for instance, unidirectional secure gateways for these highly classified networks, just communicating within the private network itself. And then there's two other capabilities, anomaly detection and big data analytics, which are capabilities that take place over time by monitoring patterns both within the network transport itself at the packet level and also at the user level and user behavior level to provide deeper insights and provide hints and patterns which typically precede major breaches. And this is becoming increasingly important as we get sort of better hacking tools in the hands of the bad guys. So putting this all together is something we call the LightSec Viewer. This is a web-based threat management system, and it enables us to manage and visualize cyber threats and how to apply solutions to these threats. Again, providing a holistic solution for cyber protection. In terms of delivery of cyber, one method that we advocate is through a network function virtualization engine. This is something we're delivering at ECI. This can be configured either as a pluggable in the ECI transport equipment or as a standalone module. An advantage, of course, of using NFV is that it can be configured through software for a customized set of applications rather than having to use a range of discrete appliances. And the modularity offered by a common NFV platform, of course, reduces the CapEx and the OpEx, and as such represents a very important telecom trend. Pulling this all together, and the context for this is ECI's Smart Light framework as part of our elastic network solutions. At the core of our product lines, which delivering the transport function, are our Apollo and NPT platforms, which deliver layer 0 to layer 3 transport with virtually unlimited capacity, which is extremely important for data center operations. This is managed through our LightSoft network management system for point-and-click end-to-end service creation. And then on top of that, we also provide a series of light apps which provide SDN-like value today on top of this transport and control infrastructure. For instance, for applications such as bandwidth on demand and scheduled bandwidth services. But really coming back to the main theme of today, this whole infrastructure is surrounded by our LightSec suite, which includes both the encryption and the cybersecurity solutions to provide overall security and comfort for your move to the cloud. So, whether you are implementing a private cloud, a public cloud, or some hybrid version, whether you are using different levels of XaaS as a service, we have the solutions at ECI to help you dive into the cloud with confidence. And thank you very much for the opportunity to provide these insights.
Thank you, Jonathan, very much. That was fascinating stuff. And I think a lot of our audience is going to be very interested in the insights in particular that you gave us into the optical level encryption. Is that a relatively new technology in terms of something which has been commercially available? How long has it been around for?
I'm not sure in the past if it's been really used with the Sonnet SDH type of technologies, to be honest, but I know that this is something which has come on board much more recently, and it lends itself very well to the OTN transport, because really there we're dealing with transparent transport, so you don't just by, if you like, muddling up the bits within your OTM frames, you automatically get that encryption. So this is something which, at least from my point of view, is something which is much more recent.
Right.
Yeah, I can just chime in there as well. This is Sterling. I can tell you that in the 15 years that I've been covering optics, it's never been mentioned as a topic in any presentation until probably the last year. So whether it may have been around for many years, it definitely wasn't of interest, at least from anybody to talk to an analyst about it.
Well, I tell you what, I think its time has come because there are so many advantages to it, obviously. But I just want to pop back to this slide which you put up, Jonathan, which I really enjoyed. Obviously, super comprehensive suite of security solutions. I think a lot of the network architects, both from service providers and enterprises who are in our audience today, are probably looking at this and saying, you know, my goodness, what a lot of work I've got to do here. Is it really necessary for people to have, you know, all 6 of these security facilities on a regular enterprise network handling sort of typical commercial applications, or is this really only something that a governmental agency or a financial institution would need to implement every single one of these options? Give us some insight into that.
I'll give you my view, and then I'll let David here maybe add on to that. The world of security is becoming more complex. I think one of the things that we see is in the past the realm of security might have been in the realm of what you would call the world superpowers, who have developed sort of, you know, very high-end software for breaking into systems. We've certainly seen that in the USA with the NSA and sort of all the amount of information that they've been able to extract in terms of people's information, databases, and systems. And just one of the trends, if you like, of technology becoming more and more readily available, a lot of those really high-end tools that I guess in the past were only available to the big superpowers of those countries that could afford them, are beginning to work their way into the hands of common criminals. This is just a sort of a natural trend of technology. So when that happens, companies need to start reacting and need to start taking more and more measures to protect their operational and IT infrastructures. So that means sort of moving from sort of, simple firewalls that will, maybe stop infiltration, or maybe forcing you to have, various, characters in your passwords, to start implementing higher levels of cybersecurity, particularly if you're concerned over longer-term threats, if you're a large company and you have a lot to protect. One of the things that we've shown in our analyses that, you've read about these large, break-ins to companies such as Target. And when you do a post-mortem analysis of this, if these companies would have deployed these kinds of tools in advance, they could have seen these threats coming and could have taken the measures. And I think as people in the industry begin to learn more and more, about these advanced tools, particularly around anomaly detection and big data analytics, and using things such as, deep packet inspection, they'll start to deploy it. So do you need all of them? Maybe not all of them, but do you need to put a suite together which makes sense for your company and your company's size and the amount of investment? Absolutely, you need to start investing more.
Well, let's do a poll question now, and I think it's a timely one. This was from ECI, provided this question. What's the most important security feature for a transport system? So if you guys in the audience would like to select, click on the radio button, which you think is the most important here. I am pretty sure what I think is going to be returned as the most popular result, but let's see what you guys think, and then we can have a chat and see what our panelists' reaction to that is. Okay, let's see if we can process those results now. I was right. I should have told you what I was guessing. I thought it would be number 2, 100G layer 1 encryption. Sterling, what are you seeing that result there? I've got 45.8% as the return result.
Yeah.
What do you think of that, Sterling?
Yeah, good news. I wasn't as confident as you, but I was kind of torn between the NFV-based and the 100G, but clearly some of what I spoke about in the beginning and what Jonathan has expanded on are resonating with the audience.
Yeah. Well, good to see that only 4.2% of people think that it's not important. Security should be dealt with at the application layer. Obviously, I guess, if more people had thought that, we wouldn't have been doing a very good job here today. Of course, if we had added NFV to the 100G option, we would have probably got 100%, given how hot that technology is at the moment. Let us, Jonathan from ECI, I mean, are you surprised by this, or is this about what you expected to see?
It's actually very interesting putting these poll questions together because you're not quite sure what you're going to get. You may or may be pleased, you may be disappointed, but I'm certainly not surprised by this. And I could almost predicted this kind of distribution. And I think one of the reasons that the 100G layer 1 optical encryption is becoming more important, maybe just to repeat a point of Sterling's, is that typically in the past, encryption was more often done at the higher levels of the stack, at the packet levels themselves. But because adding overhead to the packet, it's becoming increasingly difficult to do that as you get into the higher rates. And so it becomes easier to sort of relegate that particular role to the optical layer. So yes, this makes sense.
All right, excellent. Well, we're now going to turn to our next security expert today, Joe Cudby, who's Senior Director of Professional and Government Security Services at Level 3. And, we're delighted to have Joe on the event today because Level 3 has got a terrific reputation for security. Joe, over to you.
Thanks very much, Steve. Well, thanks for having me on. I appreciate this opportunity to talk to you guys. One of the first things that I wanted to talk about just really briefly is give a high view about sort of Level 3 and who we are. As Steve sort of mentioned in the introduction, we have been growing rapidly with recent acquisitions of folks like Global Crossing and TW Telecom. That's now got us into one of the largest Tier 1 ISPs in the world, around $8 billion in revenue, 13,000 employees. We're serving over 60 countries right now, 350 data centers, and a 36 terabit backbone. This is sort of our global IP and CDN capability, which not many people, I think, are familiar with in terms of the scale of what it is that we can actually get done these days, but it's pretty impressive. Now, what we've talked about here is really this concept of how we get to the cloud. And ECI talks about some of the security challenges that they've seen. So what do we see? So in a survey that we took of 200 IT professionals, we saw very similar requests or sort of similar challenges, right? Folks 50% wanted the flexibility to move to the cloud. And in our world, there's sort of this concept of owning the base and renting the burst. So you have your core infrastructure sitting in your own data center, maybe in your own premises, but you want to reach out to these other folks to, for sort of expansion capability. Maybe if you're a retailer, it's seasonal expansion. Maybe we need a lot of CPU to complete, certain highly computationally expensive tasks, but we only need that for a very short period of time. That's something that we see a lot, but over 60% of the respondents were very concerned about the security of this situation, right? How do you communicate with these things in a secure manner? So what's the sort of Level 3 approach to this? Now, what we've done is leverage probably our greatest asset, which is our network, right, and our backbone, and then we've developed relationships with some of the key cloud vendors. I suspect there's no name on here that our audience are familiar with, right? There's AWS, there's Azure, BlueJeans, and the HP network. And so what we've developed are relationships with these key cloud providers, and we've worked with our customers to identify how our customers want to connect and consume these types of cloud services. We want to be sort of the trusted path for enterprises and government, quite frankly, to migrate and optimize their apps within the cloud. We want to enable seamless private connectivity between people's private infrastructure and these public cloud providers. to allow them to access the scalability in an efficient and flexible way without compromising security. And to give you some sense of sort of the range of capabilities, ECI was talking about this layer 1 optical, right? How do you actually connect into cloud providers? And quite frankly, we see our customers demanding a range of similar things, right? It's not just an IPsec VPN. It's not just, hey, I want to plug in a connection as long as I'm within the data center. There's a variety of things that our customers want, right? We offer the capability to connect using a wave, right? An optical wave basically into AWS. You can do Ethernet private lines. You can do virtual private networks. You can do MPLS networks into a variety of these sort of cloud providers. Quite frankly, Google is the only cloud right now that is basically a pure internet connection. You can use level 3 pipe in order to get to Google. There's really nothing too special about that. That's one of the providers that's primarily focused on the higher sort of the security, sort of at the application level. But with the other vendors, certainly AWS and Azure, the capabilities are expanding. As we're seeing, more and more folks move their mail into sort of Office 365 and some of these other things. They want that private connection back to their office without having to go necessarily over the public internet. So there's a variety of options that we can do that. Now, the other thing to remember is that these cloud providers also have global presence. And so we can also facilitate connections to those, right? If you're a multinational company, you've got folks in the US, in EMEA, in APAC, wherever they are, we can facilitate those connections to those cloud providers using these global POPs. So really the concept of a cloud provider, it's not simply, hey, I've got gear sitting in my data center and I want to be able to plug in and leverage Amazon anymore, right? I've got things in my data center. I've got things in my head office. I've got connections all over the world. I've got staff all around the world that need to consume these cloud-based services. How do I do that? The way that we've approached it is using our Cloud Connect services, global POPs, and a whole variety of different connection mechanisms. So that's a little bit of sort of a background on us and kind of our approach. Stephen?
That was really helpful. I just had a couple of questions for you, actually. I mean, you do have an extraordinary mix of some of the largest companies in the world, including both federal agencies and also pharmaceutical companies. Do you see a certain amount of hesitancy from those types of mission-critical organizations or organizations handling mission-critical data and sensitive data to being on the cloud at all, or because of security concerns?
I think that's a great question. What we've seen, I think, typically is the concept of accessing a cloud provider over the pure internet is not something typically that these more security-conscious folks want to do, right? They want to be able to leverage something that's got a little bit more security in the transit, whether that is, as we sort of talked about, for applications where maybe latency isn't such a big deal or capacity isn't such a big deal, using IPsec or MPLS or something like that, all the way through to customers who are super concerned with latency and super concerned with capacity, going down to sort of the wave connection level. So yes, I would say that certainly the trends that we've seen and I've seen is definitely sort of away from just an internet connection and definitely more to the consumption of services using some sort of private or dedicated pipe.
And what do you think about the whole trend towards optical level encryption? Is that something which is interesting to level 3?
Absolutely. I mean, at the point where we're talking about being able to offer our customers waves and a pure optical connection, there are certainly going to be some of our customers who would be very interested in being able to encrypt at the optical level, especially as we're talking about the ability to deliver that connection with much lower latency. That's certainly something I think that would appeal to a number of our customers, yeah.
Fantastic, fantastic. Let's do another polling question because the last one was a big success. There you've got all the answers there. What's the biggest security challenge in moving to cloud? We've got some great options here. Not sure who provided this poll question. I think it was you, Sterling. Do you want to give us any context?
It was.
Yeah, good job here. You can tell you've been around for a decade. Any context on any of this, or do you want just people to just dive in here?
Well, the context is I have no idea what the response is going to come back, which is why I put this together. So this is one of the things where we'll get some interesting things from the results here and chat about them, but then when I go back and do a report, I'll definitely plug this data into there because I think we're going to get some really interesting feedback.
Well, I'm looking at the results right now, and it's pretty evenly split apart from the third potential answer, which is dealing with the increased number of vulnerability points created by the cloud. That actually makes a lot of sense to me. Does it make sense to you?
It does, and I think actually Joe, I think that might have been Joe's contribution, so he seems to know what his customers want. He added that one in, and as soon as he did it, I remembered some conversations I had recently that definitely supported that from other service providers.
Yeah. Joe, is this what you expected to see as well?
Quite frankly, yes. I mean, a lot of the conversations that I've had over the past few years, it has been around, well, if we're going to the cloud, it's the concept of the M&M, right? The hard, crunchy exterior and the soft interior. By moving things to the cloud, that hard, crunchy exterior has to get a lot bigger, and then quite frankly, you're leveraging somebody else to provide part of your sort of hard, crunchy exterior, and you don't have the same degree of visibility and control into that. So it's definitely yes. I mean, the concept of moving key things into other people's environment and leveraging other people can be daunting if it's not sort of done appropriately. So that's actually what I think would be a pretty consistent response.
Yeah, and I think it's interesting that number one didn't get a larger response, which is the application performance issue, because I think that is a sign of how attitudes have changed amongst network architects, that performance isn't the number one criteria right now. Well, both that they now are aware that there's no reason not to sacrifice performance if the network is designed properly for security. That's one factor, but also the issue of performance is taking second place to issues like security and monetizing capacity in the 21st century. So that's part of a big meta trend. But moving on here, I would like us to now move into the sort of the last and third stage of our event today, which is to discuss some of the big issues which are circulating around security and cybersecurity in the cloud right now with our panelists today. And of course, if you're in our audience today, feel free to contribute your own questions through the message board. But let's start with this top line question here, and I'm going to throw this to Jonathan from ECI first. Which parts of cloud services and solutions need to be defended? I think I know what your answer is going to be, but let's hear it from you anyway.
Oh, sorry, you have to get off mute over here. Could you just repeat the question? Which part of the cloud services solution need to be defended?
Exactly. Yeah.
Frankly, the answer is all of them. It sounds like a glib answer, but it sort of goes in line with the sort of the poll question results from the last poll question, that we have increasing amounts of points of vulnerability associated with the cloud. And certainly people that are trying to attack our infrastructures will be looking for all those different points because that's what they do. So, whether it's on the transport side, whether it's protecting, with equal defense, any private cloud implementations that you have that have previously been, closely held, or whether it's moving more into sort of public cloud infrastructures and even using things such as, software as a service, where you're probably getting some layers of security that to go along, with the particular software as a service that you're buying. Certainly, you really need to ask the questions, to your cloud provider and your cloud solution provider, how they're protecting you at all these various levels. And if you're not getting very, satisfactory answers, then you need to start finding ways to work with other third-party providers to perhaps supplement these. But that really is, again, I hope it doesn't sound too glib, but it really does go along with the sort of the concerns that I think people see.
Yeah.
Anything to add, David, or?
Yes, well, hi, it's David. It's the first time you hear me. In addition to Jonathan's remarks, I think it's very important to protect the organizational data that is moving to the cloud, either by monitoring it or also to find additional risks and abnormal behavior about the way and the data that is moving to those cloud providers and services.
Great. Sterling, what do you think? I think that you would, I assume that you would say that it's an end-to-end. You're probably hearing that it's got to be end-to-end, doesn't it?
Well, yeah, just if you think back to that poll question we just did with the concern about the increased number of vulnerabilities as you move to the cloud. Another way it was described to me recently at our event we did recently as we had a security panel, and there was a guy from the Department of Defense, and he kept talking about it in terms of insertion points. Increased number of insertion points was always a concern. So if you've got all these, you think of it maybe as a dam, and there's a crack in the dam, and then there's cracks all over the place, and they all need to be plugged. You've got to have the security to plug those holes and potential holes everywhere. So I think it does have to be across the board. And, of course, we highlighted optics a bit, and that's my area of coverage, but I wouldn't say by any means optical is going to solve every issue.
Well, I think that, I totally agree, and I think that that's really where we're going with this second question here, which is kind of a different way of asking the first question. How do you protect each level of the OSI stack in a distinct manner? I mean, we've talked about many of the solutions today, and there are solutions from layer 0-1 up through the application layer, and it's a toolbox, isn't it? Really, wouldn't you say, Joe? From level 3, you have different solutions for different parts of the OSI stack, and indeed different providers that specialize in them. And some of those solutions can be bought in a one-stop shop way, and in other cases, you need to have a look and see who has alliances with other specific providers. Would you agree with that, Joe?
Absolutely. I mean, I think to sort of dovetail back to the first part of the question in terms of parts and the OSI thing, I think they're kind of interesting and very much interconnected, as you said. I think there's some interesting things around whether you're consuming infrastructure as a service, whether you're consuming SaaS. In some of the infrastructure as a service model, you are consuming at a lower level, so more of those OSI levels fall on the customer, right? If you're consuming, virtual machines or compute or storage, all of the higher level stuff is dependent on you and your applications. If you're consuming SaaS, then really you've put a lot of that trust and a lot of that application, a lot of that burden onto your cloud provider. And effectively you, at that point, are sort of leveraging more along the lines of application security. And so I think what we'll see is it really sort of depends on where you draw the line about your responsibility as a customer with kind of the services you're consuming relative to the cloud provider's responsibility given what they're giving to you. Right? In sort of the infrastructure as a service world, it's predominantly things like perimeter stuff. It's ingress and egress. It's horizontal access. How do you stop people getting back and forth between their stuff? And it's sort of data protection and isolation. And then in the SaaS world, it's primarily data isolation. How do I keep my data separate from everybody else's? And how do I stop other people's employees from accidentally accessing my gear? So I think it really depends kind of on the service you're consuming, and to some degree how much of the burden you're placing on you versus how much of the burden you're placing on the provider.
Right, and I mean, if we focus on the end customer for a minute, whether it's a government or organization or a enterprise, as light reading would call it, or a service provider, there is so much to understand and to implement around security right now. Whose shoulders is the burden falling on? In the enterprise, is it the CIO, or is it a dedicated functionary, chief security officer? And how is that different inside a service provider organization? Whose responsibility is security within the service provider?
Great question. In some level, I would say that it really depends, again, on sort of a little bit, I'm going to say it depends, right, on the product that's being offered. Is it a way of connecting to someone else's application, in which case it's a combination of us as a service provider and the things that we're doing versus combined with sort of what the application provider is doing, right? So in sort of an Amazon world, it's a combination of us securing the link and then AWS securing their piece. in terms of where that responsibility falls, again, I think that's an interesting question, right? And some of that can depend on the staff that you have and your capability to actually undertake the scope of that work yourself. Right. So I think what we're also seeing is things like the Cloud Security Alliance, some of these other sort of certification programs as a proxy, quite frankly, for all of that work that needs to be done. Given the size, given the complexity of cloud environments, I don't know that there's that many organizations that can really undertake that themselves, except for the largest enterprises and potentially service providers.
Yeah, I agree with that, and I think that, I thought that you have an interesting title. I imagine that it invites a lot of your customers to just come to you and say, Joe, we can't we can't possibly have the resources to be an expert at implementing security at every layer of the OSI stack, within a cloud environment. Do it for us. Is a lot of your business now sort of drifting into what I might describe as sort of security systems integration for your customers, that kind of very high touch hand-holding and sort of bespoke security service now, or do you try to steer clear of that?
Level 3 certainly over the past 2 or 3 years has had a really big evolution in our scope of managed security services, and we're definitely capable and recently have been doing a lot more of that high-level hand-holding type of work. Historically, a few years ago, as the carrier's carrier, we sort of gave you the pipe and we're there, but now there's a lot of focus internally about delivering secure pipes, clean pipes, integration of DDoS and firewalls and all of these other higher level services. And then you combine that with sort of our ability to leverage Cloud Connect to actually get you into a cloud provider, and then you can leverage the services that my team provide, which are sort of a lot of the professional services concept of how to help customers get through and understand their audit requirements and how to understand and sort of speak FedRAMP and all of these other various things. That's kind of where I play. And we've definitely seen our customers come to us and say, what do I do? Help me get through this. So yes, we're definitely seeing that.
I think it's a huge opportunity for any major tier 1 operator, but obviously it requires the development of new skill sets, but that's the story for everybody at every stage of the communication supply chain right now. Everybody's having to reinvent themselves, and as we said coming in, you've been on this extraordinary streak of acquisitions, which is remarkable actually. And market cap of $20 billion now. So that must. How long have you been at level 3 for, Joe? You must have seen some changes there, right?
I've been here actually not as long as you would think, but yes, certainly in the time I've been here, I've seen changes, and watching the really, really capable teams that are doing the integration for these acquisitions, and the level of effort that's being put into that to sort of make everything as smooth and as simple and really and trying to limit the impacts on our customers with all of these integrations. That's typically something that the big companies struggle with, but I've never seen the amount of effort being applied to a smooth integration as I have here.
Cool. Let's skip the next encryption question because I think we really have covered it. I want to go to the fourth question. What are the latest trends in cybersecurity? And I'm going to throw this one over to Jonathan at ECI. What are your thoughts on this?
Thank you, Steve. So there's really two sets of trends, both within the cyber attacks and then the responses to that. I think one of the things that our cybersecurity team is seeing and sort of is predicting, based on the trends that they see in the industry, is that we will see more and more headlines coming out in terms of attacks taking place. Perhaps starting with what you want to call mission-critical networks, utility networks, and often because these are often using older technologies and not undergone network modernization as much as other networks have. We'll see more attacks into sort of point-of-sale networks, and certainly more attacks within the mobility world, both within the Android platforms and also perhaps within the Apple platforms as well. And again, just because there's much more increased susceptibility through the widespread use of these particular platforms, and we're getting more and more intelligent sort of hacking tools that are available. So perhaps to repeat the point that I said before, and I think this is really a very, very important point for our audience over here, is that you need to start looking beyond the sort of more conventional sets of tools that you've been using and really consider enhancing security in two layers. One is using multi-layer encryption. You certainly don't have to encrypt at every single layer, but if you are using something like IPsec today, you may really want to think about enhancing that with a layer 1 optical encryption to provide the additional security that provides. And if you're using certain tools like just firewalls and gateways today, you probably do want to start enhancing that with additional levels of security, such as network anomaly detection tools, big data or cyber analytics tools, and which really help mitigate against the longer-term threats about people that are exploring your networks and looking for ways to come in and getting a really heads-up on these kinds of attacks. And these are the kinds of tools that are really starting to become available on a more widespread basis right now, and we're very excited to be part of offering these things. Thank you.
Excellent. Just with Sterling, why don't you have a crack at this one as well? Latest trends in cybersecurity. What are you seeing?
Yeah, it's a great question. So, and I would tie it into maybe kind of network security. So we had our Carrier SDN event last week in Denver, which was the inaugural one. And I would say from what I'm seeing is, we spend at Heavy Reading and Light Reading an enormous amount of time talking about the topics of SDN and network functions virtualization, network virtualization, NFV. And there has been very little discussion in the industry around the issues of security on those topics. So I think it's, and I had to really pull teeth to get panelists on this panel at the event. So I think it's a topic that I think it's going to be a trend in the next year as people start to move past these proof of concepts to look at what are the implications for security. I think there's some huge ones in a topic for another webinar and a whole set of research as well. But two quick things that came up at the event were the vulnerability or potential vulnerability of the centralized controller. And then the second one, which was asked by a panelist, is can virtual firewalls and other security devices be trusted as much as their hardware predecessors? So I think it's not publicly discussed as much as it should be, but kind of a coming trend, I would say.
Yeah, absolutely. And Joe from Level 3, any comments here on the latest trends in cybersecurity?
Sure. One of the things that we're seeing, and it's been sort of addressed a little bit, right? Big data, analytics, lots of point solutions. We've seen trends in sort of the SIEM space and all of these other, what I'll call data aggregation tools when it comes to information security. The challenge is not so much the data that we have right now. It's deriving some sort of actionable intelligence from that. And I wish this quote was mine, but it's not. Intelligence is kind of the new defense, right? It's knowing, it's being able to understand and action what's happening. And this is especially true as you start spreading out your assets, right? Coming back to this hard, crunchy exterior, soft interior thing. Once you move your data, your crown jewels in some instances, out to a third-party provider, cloud provider, SaaS provider, what have you, you've really got to understand what's happening. You've got to be able to know what you're seeing, what they're seeing, and be able to tie that together in terms of actionable intelligence. So quite frankly, that's where we're spending a lot of time, is threat intelligence, looking at the big picture. One of the things that we have, since our backbone, we see about 70% of the world's IP addresses. We've got some really interesting things we're doing there in terms of threat intelligence, looking at data. Again, the key for us is how to make it actionable, right? And I think that's the biggest challenge that we're seeing in the security space. There's so many things generating so much log data, and it's all data. How do you make it actionable?
Right. Good stuff. Question from the audience here. How do you secure mobile traffic? Are there specific challenges to handling, the ever-increasing amount of traffic from mobile devices across the network? Joe, throw that one at you.
Yes, and I think there are very specific challenges with mobile, and I think, again, some of it comes back to which layer we're kind of talking about. I mean, if you're using something like LTE, that's sort of an encrypted technology by default. If you're looking at on the devices, you can use endpoint VPNs and some other things actually on the devices themselves. Then you start looking at the application security itself, right? How secure is the app? How is the app moving its data back and forth? I've definitely seen some instances where there's a lot of HTTP traffic going back and forth just with the data. Well, that's kind of bad. So even when you're looking at the app development, there's issues. When you look at the communication of the app back to the application itself, there can be issues. How you get those devices into your network can be a challenge. And really, we've sort of worked on some of these, some answers to some of these problems with some of our secure access products, but really the mobile in is a big challenge. And then it's not even simply getting from the device to the edge of the mobile network. Once you're on the mobile network and you start backhauling traffic, again, is that an encrypted link on the back end? There's lots of different places. Sorry, that's sort of a rambling answer, but I hate to say it depends again, but on some level it depends on kind of where you as a customer believe that your responsibility ends and that service providers begins.
I mean, I thought, guys, we've run out of time, unfortunately. We're 5 minutes past the hour. I know everybody's got busy days in front of them, and that goes for our panelists, but also, 600 registrants today for this event, and such an amazing mix of enterprise and government and municipality and service provider. Clearly, cloud security is an issue that impacts every organization in the communications industry right now. And I thought this was a fantastic event. So, I really want to thank, our panelists today for doing such a great job. And I really hope that you guys will come back and do some more security webinars with us because I learned a huge amount. So, Sterling, thanks so much for being with us today.
Thank you. Great to be on here.
Jonathan from ECI Telecom, great job. Really interesting stuff. Thank you.
Thank you very much.
And Joe Cudby from Level 3. Great job, sir. Thank you so much for being with us.
Thanks very much. I appreciate the opportunity.
You're very welcome. And we have a survey for you guys in the audience. I hope you'll take that. It does help us do a better job with these webinars, which is our goal. But for now, we'll say goodbye until the next light reading webinar. Thank you so much for joining us today. Bye for now.